Welcome back. This is going to be the second part of the multiple choice questions, the multiple choice questions where you're allowed to use your calculator. Now, the first thing you should do with your calculator is you should turn it off, you should clear it. You should also go to mode, which is right here. The mode button right here, first thing, mode. And then just make sure your calculator is in radian. Hit enter, and then you can hit, you can get out of there, just hit clear, and it'll bring you back to the main screen. All right, you don't want to be in degrees for this test. Now, that we're ready to go, let's go through the first question. You don't need the calculator for every question. However, the ones you do use them for will be very useful. So the first question here says, the function f is continuous on the closed interval from 0 to 5. The graph of f prime, the derivative of f, is shown. On which of the following intervals is f increasing? So here's the key. You're given the derivative graph, not the regular graph. And you want to know when the actual graph f is increasing. Now what you know is f is increasing anytime the derivative is greater than 0. And that's because f prime x equals 0 at the critical points. So that's where the graph goes from changing from increasing to decreasing. So anytime this graph equals 0, okay, all these points where it equals 0 is where it switches from positive to negative. Now it's increasing every time it's positive. It doesn't matter what's going on here, just every time between these points that it's in the green, it's increasing. Anytime it's not in the green, it's decreasing. So it's increasing here from 0 to 2, decreasing from 2 to 4, so no good, and it's increasing from 4 to 5. Okay, probably increases a little further, but our graph stops at 5. So we go over to check which one's our answer, and that would be answer D, from 0 to 2 and from 4 to 5. Nice and easy example. Good way to start, right? Now let's go to problem 77. The height of an object at time t is greater than 1 is given by h of t equals t squared minus 16 over t plus 15. What's the velocity of the object when the time is 3? Well, we're given position. To find the velocity, we have to derive. So we have our height. To get to velocity, we derive the height. Very simple derivative rule, use the power rule. X to the n equals n minus 1, x to the n minus 1, so 2t. And this right here becomes negative 16 times negative 1 is positive 16. Negative 1 minus 1 is negative 2. And the 15 just becomes a 0, derivative of constant 0. V of t equals 2t plus 16 over t squared. I just rewrote this as the denominator to make it a little bit easy, because now we're going to be dealing with our t equals 3. So to find out what the velocity is at 3, you just plug that 3 in for t. 2 times 3, which is 6, plus 16 divided by 3 squared, 16 divided by 9. Now, 6 plus 16 over 9 equals 7.778. How do I know that? Type it in your calculator. Very simple. Okay, you can also kind of get this answer because this is 6 plus 1 and 7/9. Okay, 6 plus 1 is 7. The only one close to that answer would be B. And 7/9 is 0.7 repeating. Maybe you remember that from elementary school, maybe not. Middle school? I don't know. All right, so there's number 2. 86% of the students got that right, so not a very difficult question. 78. The function g is differentiable and satisfies g of negative 1 equals 4 and g prime of negative 1 equals 2. What is the approximation of g of negative 1.2 using the line tangent to the graph of g at x equals negative 1? So everyone here, when you use your tangent line, that means you're going to have to find a derivative. And the best way to do that is with something called point slope form. That is your form where y equals y1 plus your slope times x minus x1, where x1 and y1 are your point and m is your slope. The x and the y, those are all dependent variables, and those pretty much stay the same when you're done solving. All right? So anytime you're trying to see the word tangent, please use your point slope form. And then we're going to plug some stuff in. So the first thing we need to know is the tangent line at x equals a. Well, y equals g of a, right? Because we're a point here, we're just going to say our point is a, g of a. This is our x1, y1, all right? So g of a plus g prime a, okay? G prime a is our slope, okay? And the next minus a. So we're just rewriting it a little differently. So in this case, let me erase that real quick. G of -1 equals 4. Okay, this is G of a equals 4. All right, this is technically my y1. All right, what else do we got here? We got G prime of -1 equals 2. This is technically my m. All right, and we also got a equals 1. This is technically my x1. So you can type them all in there. G of -1, which is my y1, plus G prime -1, which is my slope, x minus a, which is technically my x1. Y equals 4 plus 2 times x minus a -1. That becomes plus 1. 4 times 2 plus x plus 1. 4 plus 2x plus 2. Or what you could do here is, we could just type in G of -1.2. All right, that's what we're trying to find. That's what happens when, this means, what is G when x equals 1.2? All right, that's what we're trying to find, -1.2. So we could type it in now, or you could distribute. So I guess I did not distribute, I'm guessing. So what's gonna happen here is 4 plus 2 times -1.2 plus 1. That becomes -2/10. Becomes -4/10. 4 minus 4/10 is 3.6, or 3 6/10. All right. If you did it the other way, you distributed, and you did like 4 plus 2x plus 2, and you had 2x plus 6. All right, would have been the same thing. 2 times -1.2 plus 6. That also equals 3 6/10. Either way gets you the same answer. Do you want to distribute early? Do you want to distribute later? 100% up to you. Either way, you'll get the right answer. Awesome? Cool. Next one. Tara's heart rate during a workout is modeled by the differentiable function h, where h of t is measured in beats per minute, and t is measured in minutes from the start of the workout. Which of the following gives Tara's average heart rate from t equals 30 to t equals 60? Now you have to know the average value formula. Once again, another formula gave you on the sheet that is very, very important to memorize, okay? Average value formula of a function over AB is, here's what a lot of people forget. Don't forget the 1 over divided by b minus a, and then it's just from a to b of f of x dx. Finding a and b is very simple. A is usually the smaller number, 90% of the time. So your a is 30, your b is 60, and then you type it straight into this simple equation. 1 over 60 minus 30. From 30 to 60, h of t dt. You don't even have to solve it, you're just setting up the problem. 60 minus 30 is 30, so this is your answer right here, and you're done, right? Answer would be B. The biggest mistake made with this is a lot of people put A because they forget the beginning. You want to do the average, so it's 1 over the 1 over the difference in x's pretty much. Okay? Only 61% of students got this right. So a lot of people do get tricked. Do not forget the beginning of the average value function. Next question. Let g be the function with the first derivative, g prime of x, equals the square root of x cubed plus x for any time x is greater than 0. If g of 2 equals -7, what would the value of g of 5 be? All right, so this one's a little tricky too. So you're given a derivative, and what you want to do is you want to find what the actual value is. So to get from a derivative to the regular value, you have to do something called integration. Now we can use our fundamental theorem of calculus to solve this. So the fundamental theorem of calculus just pretty much means g of b minus g of a, all right, a and b, equals the integral of the derivative of d of x. So we can integrate the derivative and get back to the original form, and we already have one of these two things. Now, we're going to find g of 5, which is our b, minus g of 2, which is our a. Now, one of these we have. Which one do we have? We have g of 2. Why do we have it? It was given to us. What are we looking for? G of 5 we don't have. But what also can we figure out? We could figure out what this is, because we have g prime x. And if we plug that in there, we can integrate that. And because you can use the calculator, you don't even have to spend that much time doing it. So, in your calculator, first time we're going to use it, you are going to do when you get the integral. Turn on your calculator. Whoop. I haven't done this in a while. And hit math. The math button's right there. Boom. Brings you to this screen. You go down to number 9. You hit enter. Now that gives you your integral symbol. Now what you're going to do is, you have your 2, you have your 5. And then you're going to type in the integral here. Second, x squared is our square root, and it's x, the x button's right here. Where's the x button? X button's right here. X, caret button for cubed, caret, cubed, so that gives you your x cubed. You have to type in the right button, and then you got plus x, plus, and then x is right there again. All right, now here's the key. You slide over, and you have to say dx, because you're deriving in terms of x. Once you get to that, you hit enter, and it gives you the actual answer. You don't even have to do anything. So as I just showed you, you come here, you hit the math button that's right here, you go down to 9, FNINT. You're going to type in your 2, your 4, then your 2, your 5, type in the equation. Okay, so it's x caret 3 plus x, or second, x squared, and then you type all that in, and then make sure it's dx, and then you get your answer. Now, this says g of 5 minus our negative 7 from before, with a little arrow, our negative 7 from before, equals 20.899. This becomes a plus 7, and then we subtract 7 from both sides, and you get g of 5 equals 13.899, bam, which is C. All right, the calculator did all the rough work for you. Knowing how to use that calculator is going to be the key to getting a lot of these questions, especially when you do the first 2 free response questions too. That's like almost all calculator. So take in your answer, make sure you know how to use the calculator, and number 81. This one we don't need a calculator for, you just need a brain. And you need to know what some words mean. Now, if f is a function that has a removable discontinuity, you have to know what that means. At x equals 3, which of the following can be a graph? So as you notice, at x equals 3, you got some things going on here. You got pieces not connected with the point in the middle, pieces not connected where the one side has a value, pieces not connected, or these are connected, but this thing's down here, and then you got some type of asymptote over there. All right? So you got a hole, not connected, asymptote. So here's the words. Removable discontinuality.
Gonzalez, Ruben,
Removable discontinuity. Sorry, that thing messed me up. That is also known as a hole, okay? So the limit of f of x from the left to the right both equal each other. And then what happens is the limit does not actually equal the value. So look at this. So there has to be a hole. There's only one here with a hole. That's C. Right here, the limit from 3 from the positive and 3 to the negative are not equal. 3 from the negative, 3 to the positive, they're not equal. Okay? 3 from the negative, 3 to the positive, they are not equal. Okay? Because this is an asymptote. Just in case you want to know and you want to see these graphs a little better, what these limits are going towards. This one's going to infinity, this one's going to negative infinity. This one's at, I don't know, like 1, say 5. It doesn't matter, you can make up numbers. 1, 5, where like f of x or f of 3 would be 4, somewhere in the middle. Here, 3 from the negative and 3 from the positive, the limits are equal. The only thing that's different is f of 3 is not equal to the limit of 3. Okay? The limit of x as x approaches 3. They're not equal. Now there's 2 other types. So obviously the answer is C. A jump discontinuity. This means there's a gap. So both A and B are both jump discontinuities. And then finally you just get a straight up discontinuity. That means it doesn't exist ever. That would be your asymptote. So discontinuity is D. The jumps would be A and B. And the one where the limit exists, our answer, would be C. All right? Knowing what these things are, though, are the key to getting the answer right. All right, all good? Awesome. Let's go next one. Let f be continuous on a function such that the following is true. All right, now we know what the value from 0 to 17 is. We know it's 8. From 17 to 20, it's -3. And from 13 to 20, it's 7. However, we want to get from 0 to 17. So we know a couple things here. So it's a little weird, the way this is set up. I'm going to do this with this. So we have just think of it like a graph, all right? We have from 0 to 17, right? We have from 17 to 20. And then we also
Jennifer
have
Watson, report to the main office.
from 13 to 20. But what we want to get, and the answer we want, is from 0 to 13. So we want this amount. So what we have to do is we have to figure out a bunch of the different things in order to get that amount. So the first thing we know is if we're going from 0 to 13, that's the same as going from 0 to 20, right? From 0 to 20, and then subtracting 20 to 13. Part minus a whole. This brings you back to simple geometry line segments. All right, so do we have any of this? We don't,
Ruben
unfortunately.
Gonzalez, report to the main office with your things.
Wow, they're annoying. All right, they won't stop talking. All right, so we have this. We know that's 7. We don't have 0 to 20. However, what we do have is we have 0 to 17, and we have 17 to 20. So if we add 0 to 17 and 17 to 20, that gives us the answer from 0 to 20. And we know that. We know 0 to 17 is 8, and we know 17 to 20 is -3. So the distance from 0 to 20, 8 minus 3, is 5. So that tells us this whole distance is 5. And now we also know this distance is 7. So, and you're really not, it's really technically not distance, it's area under a curve, but thinking of it as distance may make it a little easier. 5 minus 7 is -2, which is our answer. Okay? Why does it have a negative value? Well, integration's area under the curve. It means more of the curve is under the x-axis than is over the x-axis. So that's how you get the negative value. All right? So hopefully that broke it down pretty easily. It's just simple algebra geometry. All right? Next, 83. Let f be a function defined above, where k is a positive constant. For what value of k, if any, is f continuous? Another fun example. So we have to find out when it's continuous. It's continuous when there is no hole, as I stated earlier in the earlier lesson, and there is no hole when you have the same value of k at 3 for both situations. So when x is 3, both of those k's have to be the same, okay? So that means that I'm going to set k cubed plus x equal to 16 over k squared minus 3. And like I said before, when x is 3, so what I'm going to do is I'm going to take that 3, plug it in for my x's. So k cubed plus 3 equals 16 over k squared minus 3. And now you use simple algebra to solve for k. All right, so actually easier than algebra, we have a calculator. So we can use our calculator and enter in both functions in a calculator, set a window up, and calculate the intersection right here. So I'm going to show you how to do this. We're going to replace our k with an x. All right, so the last thing I typed in my calculator was this. This is annoying to do. All right, so I hit this. I am going to hit the y equals button. The y equal button is right here. Boom. All right, that's from a previous problem. I'm going to type both those equations in. So the first one I'm going to do is k cubed plus 3. So I'm going to type in x caret 3, hit to the right to get down, plus 3. All right, and then I hit enter. I go to the bottom one. Then I'm going to do 16 divided by, make sure you put the bottom in parentheses, x squared minus 3, close parentheses, and enter. So I got both these in. Now if I hit graph, this is a graph from a previous problem. I don't have anything on here, so I got to change my window. Since we're going to be around x equals 3, I go to window, x max, say -1-ish. I'll make that a 5, that way I'm there. Y min, I have no clue what this is going to be, so I can make this like -15, y max 15. That's just a guess. I hit enter and hit graph, and then I look at my graph. And the thing here is I'm looking for intersections. Now I don't see it up there's an intersection right around 3, right at that top piece. So what I could do now is, since I have this on my graph, I am going to go through the calc intersection button. I hit the second button right here, second, and then trace, which is calculate. I go down to intersect, number 5. Hit enter. I hit enter and enter. That's both graphs. And then I hit enter by the piece, and it tells me the intersection. 2.081254. All right, let's go to the y value as well. So I have my stuff in my calculator. In this one, I went from -10 to 20, so it was a little different. Calculate, which was second, trace. Go down to 5, intersect. I hit my intersection, and here's the key. It gives you your answer right here. You want the x value, okay? So you want the value of k. I just replaced k with x. It's fine to do. 2.081, which is right there. All right, good thing there's not even a 12, so y wouldn't even be confusing with you. All right, so once again, the way to use your calculator is you're going to hit the y equals button first. All right, that brings you to this screen. You type in both your equations. Then you go to your window button. Okay, since our x is around 3, that's why I went a little bit above 3, a little bit below 3. And then I just try to pick a big window for the y's to make sure they were in there. It was. So then I hit the second, and then the trace button, which is calculate. All right, there's an x here. I hit enter, enter, and then I hit the enter by here, and that gives me the intersection right there. And that's all there was to it. Nice and easy. All right, that's 83. Now you know how to use that to find when things are equal. 84, table gives values of a continuous function. Nice. F, at selected values of x. Based on the information in the table, which of the following statements must be true? All right, so the first one says what has to be true. Does f have to have at most 1, 0? Does f have a relative, maximum? What do we got? So when we do this problem, first thing I'm going to do is I'm going to plot these points. -5, 1, 2, 3, 4, 5. -9, 0 over 1 up, and 2 over 5 up. So I got my points plotted, okay? You can make your own plots. They're not going to be on the paper, but just drawing your own plot makes things easier. So based on the table, which following statements? That's all I got right now. I know that my f of b is going to be one of my highest b values, right? So b, this point right here is b, f of b. This point down here is a, f of a. Because the f of a, f of b are just your y values. So there exists a point here that has the following. Does f have at least 1, 0? Is that true? Does f have a relative maximum at x equals 2? Do we know if that's true or not? Is there a value c where it's between -5 and 2? Such that f of c somewhere has to be 4. That might be true. Because this is 5. And this is, what's this one? -9. All right, so there has to be a 4 somewhere in there, right? What else do we got? Is there a value c? Well, we're going to use the intermediate value theorem. What is that? If f is continuous on the closed interval, there is a k between f of a and f of b, where at least one number c is between these numbers. What's this? -5 and 2. So there's a c between them, and there's an f of k between them. So your answer actually is c. There's a value c between -5 and 2. So there has to be a c in here, all right, where the answer is going to be 4. Where f of c is 4. And f of c being 4 means one of these values here has to be 4. We don't know about the derivative. That's what makes this one wrong. We don't know where the relative maximum or minimums are. And at most 1, 0, we don't know. It might just go like this. It might be no zeros. It might just go up forever. Right?
At this time,
All right, now,
all
number-
IMU participants, please report to the learning commons.
85.
Thank you.
They can't be quiet today. All right, number 85. The function of f is an antiderivative of the function of g, defined by g of x equals 3 minus the square root of x squared plus x plus 4 cosine x. Which of the following is the x-coordinate of the location for a local maximum of the graph of y equals f of x? Ooh, that's a lot. So, local max, as we said before, is the first derivative, right? So when we find the local max, we want to know when the derivative, maximum, goes from being positive, that's a positive slope, to a negative slope. And then you get your local max right there when it switches. All right? So we got to find that out. So that means we have to find out the derivative of this equation. Okay, so going up to down. Now, g of x equals the derivative of f of x. How do we know that? Because it says f is an antiderivative of g. Okay? Antiderivative means like the opposite of derivative. All right? So that means g, f is the derivative of g. All right? And that has to equal 0. When that equals 0, that's where you're going from increasing to decreasing or decreasing to increasing. So once again, we're going to go to our calculator. You're going to enter in the functions because we want to know when they equal 0. Now this one's pretty easy to do. You're going to enter in the function. I'll do it here again, even though it's on the board. Okay. So you have your function here. And when you have your function here, what you're doing is you're going to go back to y equals. Okay, y equals. I'm going to clear my last one. Whoops, clear. Go up to here. Whoop, moving some stuff. And you got your equation is 3 minus, all right, second x squared. All right, this is going to be x squared plus x plus 4 cosine x. All right, and then what you're going to do is you're just going to close that cosine and hit enter. And your second one is when they equal 0, so you just make it equal to 0. Enter. Okay? So now we have that. Move my desk a little bit that this is on. And you're going to see where they intersect. So I'm going to change my window from, let's just say, -4 to 4, because I want to be around 0. My scale is going to be 1. My y, I don't know what my y is going to be. I'll just say -2 to 2, because right around the 0, and I hit graph. I look at my graph. I just care where it crosses the zeros. All right, now, there's my graph right there. And it intersects in 2 places. Okay, so if we look at the front, you can see it intersects in 2 places. Now here's the thing. The intersection I care about is 3.14 and not -4. The reason -4 doesn't matter is because that's actually a local minimum. Okay, that's going from negative to positive. Okay, see how this down here, these are all the negatives, these are all the positives. So this one's actually, this graph looks like it's going from down to up at this point. This point here, it's going from positive to negative. That's why I want this intersection here, because this means the graph is going up, and then when it's down below this line, it means it's going back down. So that's my local maximum. And once again, to find that intersection, you just hit the second, calc, you go down to 5. Now to make sure you're by the right one, press the right button to get closer to that intersection over there. Hit enter, enter, and then just try to get close to the intersection we want. And then hit enter again, and then we're there. All right, 3.14. Not too terrible. Only 54% at that, but it's not actually that bad of a problem. All right, got a couple more problems to do and we'll be done. The graph of y equals f. All right, so the graph of f of x on 0 to 5 is shown, which of the following could be a graph of y equals f prime x. We're almost there. So first thing you have to do is you have to look at your graph of f, and you see that there is a positive slope from 0 to 2. What that means is my graph is rising from 0 to 2. As you can see here, it's just going up. And then once it gets to 2, what my graph does is it starts to go down. When it goes down, that means it has a negative slope. And it goes down until it gets to this point. And then what happens is the slope becomes positive again. And then when the slope becomes positive again, it changes over. Now these graphs right here are my graphs of f prime x. Okay? Now the way this works is when f prime x is greater than 0, the graph is rising. When f prime x is less than 0, the graph is falling. So anytime you have a positive slope, your graph is going to be above the x-axis. Anytime you have a negative slope, the graph is going to be below the x-axis. So if we go and just highlight these as green above, red below, we could figure this out. So this first graph, you hit the x-axis and you change over twice, right here and right here. So from 0 to 2, it's a positive slope. From 2 to 3, it's a negative slope. And from 3 to 5, it's a positive slope, which looks pretty good. It looks like it might match up exactly like this one. But let's just check the other ones to make sure we're doing it correctly. This one right here, it switches over right at this point right here. So from 0 to 3, it has a positive slope. And from 3 to 5, it ends up having a negative slope. No good. All right, so this one right here. This one, it's negative slope all the way from 0 to 3. It doesn't matter if this graph is increasing or decreasing. That has to deal with concavity, not anything to do with increasing, decreasing. So from 0 to 3, it's a negative slope. Right away, we know our answer is bad. And from 3 to 5, our answer is positive slope. Now, D has some potential. It does have the 3 splits like this one. From 0 to 2, it is a positive slope, good. Negative slope, though, from 2 to 4. But we want 3. And then positive from 4 to 5. So once again, D is not a good candidate. Our answer would end up being A. All right, nothing really to it. Pretty easy stuff. All right, that's 86. Only a couple more problems to go. I think 4 more problems. 87, at time t, 0 t to 2, the velocity of a particle moving along the x-axis is given by a v of t equals t sine t cubed, where t equals b, be the time at which the particle changes direction from moving from left to right. What is the total distance traveled by the particle during the time interval from 0 to t to b? All right, so what are we going to find out here? We want to know the total distance traveled in this time period, so we need to find out what b is. All right, so in order to do that, when the function goes from negative to positive, that's when it's going to change direction, okay? Positive velocity is forward, negative velocity is backwards, okay? Now the total distance of something is when you take the absolute value of its velocity and you integrate it, okay? Because the integral, the position function is the integral of the velocity function. Now with total distance, that includes the distance above and below. All right, I don't think we need to go into my Apple settings here, but that's okay. All right, now we're going to enter both functions into the window from negative 0.5 to 2.5. Why? We're just going like minus a half and plus a half from what we actually care about, just to give us a little bit more, and then see where they intersect. So when you do this, the two functions you're plugging in, we want to know when they equal 0. So once again, I'm going into my calculator. I'm typing y equals, all right, y equals right here. I'm going to hit clear, all right, and I just hit X, sign button, X caret 3, close parentheses. Whoop, see how my close parentheses up there? Don't want that, so I can delete it to the right and close my parentheses and hit enter. And my second point is just going to be 0. Already have it. Awesome. My window, as I said before, window, let's make x from negative 0.5. Whoops. I'm just going to clear this whole thing. negative 0.5, enter, and I'll make it to about 2.5, enter, and I don't know what my y's are going to be, so I'm just going to pick like, keep my scale 1, like negative 10, the 10 to start with. I don't know, I just always guess. Put a thing here, let's see how this works. Oh, see how that graph, that's really bad? That's really tight. So I can lower this down. I want to get it even closer to 0. So I go to window, my y's are going to be, I'm just going to make it negative 2. Delete to 2. Delete. I want to graph that. Now it looks nicer. And that was just a guess, because I want to see where it intersects 0. Now the only places, I'm going to go put this on the board, because it's hurting my arm to do this, where it intersects 0. It intersects 0, we want between 0 and 2. So 1, 2, so anything after here doesn't count. So it intersects in 2 places. The 2 places you're going to have an intersection are here and here. Okay, there's kind of one over here too, but it really doesn't. It looks like that's more of an asymptote. So what we're going to say is our answer is going to be this one. This is the intersection we want. Now the reason for that is we want to know where this goes from negative to positive. Well, this is negative down here, this is positive here. So this point's going from positive to negative. All right, so this is going from up to down. So this is more of a maximum. This one's going from negative to positive. So that's the one we want. All right, because we want it from, when it changes direction, moving left to right. So left is our negative, that's our positive. This is where it changes from moving right to left. So that's the opposite. So to do that on a calculator, to make sure we're at the right one, we hit second, calc. We're going to go to number 5. You could actually just hit the number 5. Intersect. Now we're going to have to go all the way over here because we have to move it. So I'm holding this arrow. All right, I'm going to hold it till I get close to this point, because that's the one we want. Enter, 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 and then it gives us our intersection. All right. Now, what this means is we want the total distance now and the absolute value. So we have to do an integration. Now, when we do an integration, we just found out what b is. So there's a second part to this. So now I'm going to go to here, hit clear, get back to here. I'm going to hit math button. I'm going to go down to number 9, hit enter. All right, now this is 0 to 1.8, 1.845. All right, type in, instead of t, we just put an x, sine x caret
Sonia Odom, please report to
right
the Academy office. Sonia Oman.
x. All right, and then enter. 0.212. And look at that. Bam. Bam. Uh-oh. 0.212 though is wrong answer. The reason it's wrong is you must use your absolute value symbols. So I tricked you. So see this? All for nothing. We have to go back. Math. 9. All right, we're going from 0 to 1.845. All right. Now, when you type this in, I said you had to use absolute value. That's under math. You have to click to the right till you get to number, and ABS is absolute value. Answer has to be an absolute value or your answer will be wrong. X, sine, x cubed. Close your parentheses. dx. Enter. Now when you do this, notice what answer you get. You get the right answer, which is 1.011. Notice they're going to put the answer there that doesn't use absolute value. You have to be very careful. This is a no. Make sure you have your absolute value symbols in there. If you don't, your answer will end up wrong. All right? Next one, 88. Let f be the function defined by f of x equals 1/4 of x to the fourth minus 2/3 x cubed plus 1/2 x squared minus 1/2 x. For how many values of x is the open interval from 0 to 1.565? The instantaneous rate of change of f equal to the average. Now, average rate of change is just the slope formula. F of b minus f of a over b minus a. Okay, so what we could do here is very simple. You have your a, you have your b. To find f of a and f of b, you plug them into that equation. So first one's easy. If I want to do f of a, I get 0, and f of the other one is, I didn't do it. So to find f of this, I would just do 1/4, 1.565 to the fourth minus 2/3, 1.565 to the third plus 1/2, 1.565 squared minus 1/2 of 1.565, and that gives me this. All right, with the 0, I would just plug the 0 in. 0, 0, 0, 0. That's where I get the minus 0 from. All calculator work, you type it in. All right? I'm going to erase that. Now, instantaneous rate of change is just your derivative. So what you're going to do is you're going to derive this. Very simple derivation. You get 1/4, so d dx is, I'm just going to do it right here, 1/4 equals 1/4 4x cubed minus 2/3 3x squared plus 1/2 times 2x minus 1/2. All right, 1/4 of 4 is x cubed. 2/3 of 3 is 3 minus 3x or minus 2x squared. That's 2, I mean. Half of 2 is x, and then you got your minus 1/2. All right? You are going to set them both equal to each other. All right? I am going to set this equal to this on my calculator. Okay, so on the calculator, once again, here we go with the calculator. I'm going to set y equal. I'm going to type them both in. I'm going to do it down here just to do it quicker. X cubed minus 2x squared plus x minus 1 divided by 2. Enter, and the second one is negative 0.392. Enter. So this is what you type into your calculator. You're going to hit graph and see how the graph looks. See if I can get a graph here. And it does cross the x-axis there. So I can use it, or actually we've got to use it between -1 and 0. It crosses a couple times. All right. How many times do you see it intersect? I'm going to change my window, make it a lot smaller. My window, my y max can be like -1.5. My y min, my y max can be maybe 1. And what I do is I'm just shrinking down my y maxes and y mins just to try to get a better answer. It looks like I got 3. I'm going to change my window again. I'm going to make my y max equal to about 0. All right, I got another graph right here. And this lets me see it a little better. 1, 2, 3 times it hits. All right, 1, 2, 3. So the answer is 3. How many values is the instantaneous rate of change equal? It's equal 1, it's equal 2, it's equal 3. You can actually find out when they're equal using your calculator if you like, but you don't have to. All right, 2 more. Let g be a twice differentiable function with g prime x greater than 0 and g double prime x equal greater than 0 for all real numbers, such as g of 3 is 12 and g of 5 is 18, where 20, 21, and 22 are possible values. This is a very easy thing that can be done by graphing. If I graph 20, 21, and 22 on a graph, watch what happens. I'm going to graph g of 3 is 12. I'm going to graph g of 5 is 18. So what happens here is, if I do a graph here and I connect these two, that's pretty much the slope of that graph. But what happens here is, this right here says the graph is increasing. So we know it's going up, so it can be any of those. But here's the key. This right here, g double prime of x. What that means is, we originally have a slope of 3, and it's increasing, so the slope is increasing. So that means the slope after this point, so technically, this is probably more of something like this. The slope is going to be greater and concave up after this. So any value of slope is going to be, I'll show you, greater than 3. So since this is where 3 is, a greater than 3 concave upslope would be something above that point. So the only value above 21 that's listed here is 22. Okay, this would be okay if it was concave down and decreasing. This would be okay if they were the same and this actually equaled 0, remained the same. But because this is both increasing, that means it has to be above where it normally would be. All right, that's a pretty easy question. Ready for the last one? Number 90. Number 90. Table gives the value of differentiable function of f and its derivative at the selected values of x. Is g the inverse function of f? Which of the following is an equation of the line tangent to the graph of g at the point where x equals 2? That's a lot of words, but it's very easy. These are the derivatives, and these are the regular f values, f of x's. So this is like your y. This is like your derivative when you type in x, and this is your actual x. So the inverse, f of g of x, the inverse of f of g of x is actually x. So that's the first word, the word inverse, all right? We see the word inverse here. G is the inverse function of f. So when I derive f of g of x, this is a simple chain rule type problem. I am deriving x because the inverse equals f of g of x equals x. The derivative of x is very simple, is 1. But what we can do here is u equals g of x, f of u prime is g prime f of u is f of u, f prime u is f prime. The reason we have to go so crazy with this is we're going to have to put everything back in here. So when I use my chain rule to solve this, this is just g prime times f prime u. All right, and then when my u is g of x, so that goes in here. So it's g prime x times f prime u. That's the derivative of this. And the derivative of x is just 1. Right? So now let's look. It says, well, we know x equals 2. Why do we know x equals 2? So when x equals 2, we have to go over to here. So g prime of 2 times f prime of g of 2 equals 1. Because we're just typing in 2 for x. Now here's how it works. Since we're doing inverses, that means opposite, okay? So since this is normally x and this is normally y, we flip them, right? So in g of 2, we have a 3. Okay? So f negative 1 of 2 is 3. G prime 2 is the same as g of 2. And now it equals 3. Okay. G prime 2 times f prime 3 equals 1. And the reason for that is I took all this and I just replaced this with that. Okay? So this has nothing to do with this problem. This is just solving for this. All right, that's where I got this 3 from. And now we can solve. G prime 2, f prime of 3, f prime of 3 equals 5. Oops, let me use a different color so I don't confuse you. This equals this, f prime of 3. All right. G prime 2 is what we're looking for. That equals, we divide both these sides by 5. 150. All right. So that is our m. So now what you have to do is you have to do the tangent equation. Y equals m x1, y1. Our x1, y1s are going to be 2, 3. Why are they 2, 3? Right here. 2, 3. All right. right, so that's it. Probably the hardest problem there, but you guys get it. So hopefully you did well. You understand how to use the calculator a little bit better. And the next thing you're going to go over from now on is going to be free response questions over and over and over. But these are the multiple choice questions that you will see on the part where you can use the calculator. All right? So until I help you out next time, have a great day. Study up.